Hi, I'm Professor Elaine Holmes, and I run the Centre for Systems and Computational Medicine at Murdoch University in Western Australia. So the Centre for Computational and Systems Medicine is a group of academic staff at Murdoch University who are dealing mainly with metabolic profiling data, looking at metabolic phenotypes of people in various either physiological conditions, like what does exercise do for you, what does a particular diet do for you, but also pathologies. And two or three of our biggest ones, I would say, would be things like cardiovascular health, metabolic syndrome and diabetes. Also neurodegeneration, we do quite a lot of work around that, but more recently, we're doing a lot in the infection sphere, particularly looking at COVID-19 in terms of looking at the impact of the virus itself. What does an acute infection do to the body, and what does the variation between people mean? But also looking at long COVID and the people who are left with residual infections or residual symptoms, after the actual infection has gone. And we have a sub-study at the moment, which is also looking at the COVID vaccine and seeing how various people respond to the different vaccines, predominantly AstraZeneca and Pfizer. But that's also interesting because people respond very differently metabolically to the vaccine too. Well, the vaccine study is literally just being analysed now, but from the other studies, what we've found is that around 60% of people who have the COVID infection, regardless of the severity of infection, have some sort of metabolic derangement, and it'll express itself in people in different ways. Sometimes it'll be the lipid machinery or the lipid metabolism that changes, and you'll see possible indicators that the cardiac health isn't as good as it should be. Other people show signs of liver dysfunction. Other people, perhaps associated with the neurological symptoms like loss of smell, loss of taste, also show disruption of chemical pathways that have previously been associated with neurological conditions. So everybody's a little different. What we're finding is that if you track somebody metabolically, you can see a sequence of chemical profiles, phenotypes, and most people don't actually return to normal within the first 3 or 6 months. We're looking further, of course, but we're up to now, we're looking up to 6 months. Well, Jeremy Nicholson, who's head of the ANPC, started up the network along with Manfred and Bruker. But I think we have a very strong motivator in COVID research. When we started out on the research, it was apparent that several of us had actually had the virus itself, and Jeremy found himself with long COVID. So it's kind of become almost a group obsession. Everybody's been tracking themselves. But as we got more deeply into it, and it was apparent in Western Australia, because they did such a good job initially, we didn't have too many cases. And for that reason, the thought was, well, let's look to our collaborators, let's see how we can help them out, and let's see if we can all get together to provide a more global profile of this virus and what it's doing. So I think that was the motivation for reaching out to the collaborators and saying, what does it look like in Germany? What does it look like in Malaysia? And just trying to get a better picture of the metabolic consequences of this virus. Well, it is known that there are factors that predispose you to worse consequences of the virus. So two of them being if you have diabetes or metabolic syndrome in the first place, or cardiovascular problems, also obesity or high BMI. That's another starting condition, if you like, that often leads to poor outcomes. So whatever you have as a disease, the virus seems to tip you more into that disease. So it kind of speeds up the disease process. But equally, there are people who are apparently healthy metabolically, so they don't have they don't have the constitution, if you want to put it like that, or starting phenotype that would predispose them to the virus, and yet they still get it. And they, there seems to be, for some people, yes, there's some merit in predicting who might get it badly based on pre-existing conditions. But for other people, there are other metabolic factors, and we're just starting to work those out, that don't start off as a disease, but those people still get serious adverse consequences of the virus. So everybody responds a little differently, it seems. And one of the mechanisms the virus works is via inflammation. It induces a cytokine storm. And I think people's bodies are different in the way they react to inflammation. So it's almost as if your own body's attacking itself. So the virus is encouraging your own body to go into overdrive. And I think that is causing a lot of the issues we're seeing that go along with COVID. But you can't just look at somebody and predict you're going to be fine or you're going to have a very bad reaction. There are predictors or things we can say you might have a bad reaction, but it doesn't always follow. So we do need to do an awful lot more work. Well, we've got a sort of two-pronged goal, really, in terms of looking at vaccination. One is just simply a characterization of what happens after you get the vaccine, because anecdotally, people behave very differently after the vaccine. Some people say they're absolutely fine. They didn't even get a sore arm. Other people have a sore arm. And there are people, particularly after the AZ vaccine, who are saying they have a headache, really severe headache that lasts weeks, and other side effects too. So for some people, the vaccine obviously has a stronger effect on the metabolism than other people. So again, our interest is in, what can the virus do? What can the vaccine do? How do we respond to it? And can you predict who's going to react in one way to a particular vaccination? So can we get to the stage where we say, well, you'd be better with the AstraZeneca vaccine, you'd be better with the Moderna, the Pfizer, and see if we can do a little bit of personalized vaccine medicine.